Hello everyone, welcome to this video. In this video, we'll be solving this question which states that for any group element A and for any integer k, we need to show that the centralizer of A is contained in the centralizer of A raised to power k. So let's go through the questions one by one. For showing this thing, we need to take some element here and we need to prove that it is also present in this centralizer. So here, in order to show this thing, right, we take z from the centralizer of A. So by definition it would commute with A, so za would be equal to az, right? So in order to show that z also belongs to this centralizer of A raised to power k, we need to show that z of A raised to power k is A raised to power k of z. So that means z commutes with A raised to power k. So we consider the left hand side over here. So now you can very easily write the A raised to power k as A into A raised to power k minus 1. There is no issue, right? I have done the same and I have took the bracket here. Now we can use equation 1 here to write it like this, az, right? Next, what you can do, you can now express A raised to power k minus 1 as A into A raised to power k minus 2. So this is what I have done over here, I have expressed A raised to power k minus 1 as A into A raised to power k minus 2. So now the whole of this thing is az, again using equation 1. So we can continue this procedure until we obtain this last step where we have A raised to power k minus 1 here and za here. Again we can use equation 1 to write za as az because they both commute with each other. Now you can club up these powers to for it to become A raised to power k into z, right? So from here you have z A raised to power k, this is equals to A raised to power k into z. This is what you have from here. So that means z would be a member of the centralizer of A raised to power k, and this is what we have to show for the first part. For the second part, they are saying that use this fact to complete the following statement. This statement is given to us that in a group, if x commutes with A, then what will happen? So if x commutes with A, what does it mean? X belongs to this centralizer. So that means it would also belongs to this centralizer. So that means, and this is true for any integer k. So that means we can take any power of A. So we can write the statement like this: in a group, if x commutes with A, then x also commutes with all the powers of A. Now this is the result over here. And the third question here asks you, is the converse true in this particular case? So let's check it. We wanted to show that if the centralizer of A raised to power some k, where k is some integer, is this also present in the centralizer of A? The answer is no, this is not there. The converse is not true. That means if x commutes with any power of A, then it is not necessarily that x would also commute with A, right? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.